So where I left off, I have a few zeros already picked out. I already have 2 of them, and I have 4 more rational zeros to test. So I'm going to test this expression, and I know it's not written the cleanest, but it's 1, -1, 4, -4. So I'm going to test 4. And I'm using my simplified expression. So this wasn't a 0. Let's check -4 now. That was a negative, so this would be a -36, but it still didn't work. So if I plug in -4, that one didn't work either. So we have 2 of them still. So we still don't necessarily know what we have for our other zeros. Okay? So I have to check 8 and -8. So if I check 8 and -8, we're going to run into the same problem. So we have an issue. We have this expression x cubed minus x squared plus 4x minus 4. We've tested all of them and we've gotten 2 zeros. Now, normally we can't do this, but if we try this, let's see if this is factorable, because usually we try this only if it's the degree 2. But if I put these all in this expression, if I multiply these 2 things together and multiply this diagonal, I get the same thing. So because I multiply the diagonals and get the same thing, this is factorable. So that's a 4. This is a -1. This is x. This is x squared. Now you might say, well, how did we not find this any of these zeros? So this factors into x minus 1 times x squared plus 4. Well, this 0 is 1, so how did we not catch it? And the reason that we didn't catch it is because we already got 1. So 1 actually got repeated. That's one thing that you have to check. You might be able to find a repeated 0 when you use this. So here's the issue. We have 2 zeros. We have a repeated 0. And now we have this last thing we have to check. We can't factor x squared plus 4. But if we set that equal to 0, I get x squared equals -4. And if I square root both sides, I get x equals, well, the square root of 4 would be 2, but since a negative square root, we have plus or minus 2y. So what I have are these 2 roots, this one right here, which is 1, this one, and this one. So I have 1, 1, -2, plus and minus 2y. So here's how I write this. My roots are 1, 1, -2, plus and minus 2y. So if I write this as the product of linear factors, it's going to look like this. The plus 2y would look like this. The minus 2y would look like this. And this is my product of linear factors for this problem. Now, be sure to look at the exercises for this when I have them posted for this set, because as you can see, this is a fairly time-consuming task to try and find all the zeros for this. And you need to make sure that you try this a couple of times before you move on to the next section and feel ready for the test.